In 1977, the first Star Wars movie, A New Hope, released in theaters, and the world was never the same. Who wouldn't want to hop on the Millennium Falcon and travel from a moisture farm on Tatooine to the Ewok villages on the forest moon of Endor? And, in fact, that's exactly what the characters in the original trilogy do. The story begins with Luke Skywalker on Tatooine and ends with everyone celebrating on the forest moon of Endor. If you didn't know already, there are many scientific problems with the universe of Star Wars. In this video, we're going to explore one potential scientific issue in the galaxy far, far away. What is the gravity like on Tatooine? What about on Endor? Would Luke Skywalker have a difficult time adjusting to the difference in gravity between the desert planet and the forest moon? We can use information from Wikipedia, some estimations based on planets in our galaxy, and a few basic physics formulas to discover the gravitational pull on both Tatooine and the forest moon of Endor.
In order to find the gravitational pull of a planet, we will use this formula. The big G is Newton's constant of gravity, or 6.67 times 10 raised to the 11th meters per second squared, which means we need to find the mass and radius of our respective planet and moon. Let's start with the planet Tatooine. On Wikipedia, we can find that the radius is 5,233 kilometers. SI units are used in our calculations, so we will change kilometers to meters, leaving us with 5,233,000 meters. Then, following the formula, we square it, giving us 2.74 times 10 to the 13th. But there's a problem. Wikipedia doesn't list the mass of Tatooine. Lucky for us, there's another way to find the mass of a planet. Density times volume equals mass. We don't know the density of Tatooine, but for the sake of this video, we can make an estimation based on the average density of rocky planets in our solar system. To find the volume of Tatooine, we can use the formula 4/3 pi times radius cubed. Using 3.14 for pi, we get 6 times 10 raised to the 20th meters cubed. Now we can do the formula. The mass of Tatooine is 3 times 10 to the 24th kilograms. Now that we have the mass and radius, we can find the gravity of the planet. G equals 6.67 times 10 raised to the negative 11th times the mass of Tatooine, which is 3 times 10 raised to the 24th, divided by the radius squared, which is 2.74 times 10 raised to the 13th. This gives us a gravitational force equal to 7.3 meters per second squared on Tatooine. Now we'll go through the same steps for Endor, which gives us a gravitational force of 3.4 meters per second squared. What does this mean? It's a decent change in gravity. On Tatooine, you would weigh 75% of what you would weigh on Earth. This is similar to the planet Venus in our solar system. Gravity on Endor is 35% of Earth's gravity and is similar to the planet Mars. There would definitely be some differences, but it does make sense that you would be able to walk all right on both planets, as is shown in the Star Wars movies.
Since Star Wars is fiction, there are lots of estimations we have made that could affect our results. For example, if the forest moon of Endor is significantly denser than Tatooine, it would have higher gravity, and the difference in gravitational pull might be even smaller. We hope you enjoyed this exploration of gravity on the planets of Star Wars.